What do you want to see?
Could we do number 9?
Yeah.
Number 9? Okay. All right, so I'm going to just let me read the question, and then I will talk about the setup here. We have Jet A traveling east from San Francisco towards St. Louis. So we have Jet A going in this direction here. Jet B travels north from New Orleans up north to St. Louis. Find the rate of change of distance between the two jets. We're looking for dz dt. We know it's a Pythagorean theorem problem, so we're setting up our equations that way. Pythagorean theorem, derivative with respect to time. So we have to list out all the variables, and we have to start assigning values to these variables. So one thing that I want to point out is what is going to be different about dx dt and dy dt that we have to be careful about.
Would dx dt be negative?
Okay, why is it negative?
It's going right.
Okay, not the direction. There's something else that's causing dx dt to be negative. What's happening to this length of our triangle?
The distance is decreasing.
Good, distance is decreasing, right? As Jet A gets closer towards St. Louis, that distance to St. Louis is getting smaller, right? So dx dt is going to be negative, right? So that's something to be careful about. So that means as we build our mile per hour, we got to change the sign to be a negative. What about Jet B? How about what about dy dt? Positive or negative?
I think it's positive.
Okay, so it's going north. Okay, so I think sometimes we associate north with positive, which is possible. But what's happening to this length?
Would it also be negative? It's getting closer to St. Louis as well.
It's getting closer, right? It's getting closer. It's causing this length of our triangle to decrease. Now, if we're going from St. Louis to New Orleans, then that's different, right? Then our y is increasing. But we always want to kind of picture what's happening to our triangle, right? If you can imagine that length increasing, you want that rate to be positive. If you can imagine that rate to be decreasing, then we can make it negative. All right, so I think that's the only difficulty of the problem. Everything else is kind of given to us. All right, so x is 100, z is 300. I use Pythagorean theorem to figure out my y value. dx dt and dy dt are both negative, so I'm expecting dz dt to be negative as well, right? As the triangle is getting smaller, we expect all three sides to be getting smaller, so dz dt coming out as a negative should make sense for us. Yeah, so it's just a bunch of big numbers that we're just entering in the calculator and solving for dz dt. All right, good. What else you guys want to see?
Could we do number 11?
Yeah. So 11 goes back to being a cylinder problem. And we talked about how cylinders are easier than cones because we don't have to worry about similar triangles. We don't have to worry about the radius getting in the way because the radius is going to stay constant the whole time through. And we can just remove r from our equation, and we can replace it with a number because it's a constant. So a couple of things to keep in mind with these problems, with cylinder problems, is that the first thing is there's no similar triangles. Even though the formula looks a lot like cones, second thing is that the radius is a constant. Okay, which will make this problem easier because we should be able to work through this problem without having to look at radius variable. Okay, third thing to watch out for is watch out for extraneous information. Sometimes the problem provides us with information that we are just not going to need. And the danger is sometimes we want to involve those values in our problem, and we think we're doing something wrong because we're not using everything that the problem gives us. So just be careful about that. Sometimes that happens to come up more so on these cylinder problems. So let's see if we can gather some information. Water is leaking out of a container at a rate of 2 cubic meters per hour. We know that we're dealing with volume. We know that we're dealing with a rate. So it must be dV dt. Water is leaking out, so we know it's going to be a negative rate. Diameter of 8 inches. Height of 12. At what rate is the height of the container changing when the container is half full? So let's gather some information here. What's the radius?
4.
Okay, radius of the container is 4, which is also the radius of the water level, right? Is that value going to change as the water keeps dropping?
No.
Doesn't change, right? So we can.
So that's just because it's a cylinder, it doesn't change, whereas in a cone it
Exactly,
would.
right. With
Okay.
cones, it does change, but cylinders, it does not change.
Okay, thank you.
Yeah. So cones, I know the formula looks very similar, but the way that cones are shaped, the radius is going to change, but not for cylinders. Okay, and then half full is when the height is what?
6.
6. Okay, so let's see if we can make our equation easier. We said that radius was a constant. We can replace that r and not have to deal with that variable anymore. So what does this equation come out to be?
16 pi h.
Mm-hmm. So the nice thing, right, we don't have to worry about replacing r. We don't have to worry about creating another equation with similar triangles. I mean, we're ready for our derivative, right?
Can I ask a question real quick?
Yeah.
So in this problem, would extraneous information be the height of 12 because we're not using
Yeah.
it?
The 12, the 6, we don't need these,
Okay.
right? We don't even need this information. Now we do need it if it was a similar triangle problem,
Mhm.
but it doesn't even play a part in our problem, right? It doesn't
Okay.
matter what the height is. Our DHDT is not going to be impacted by how much water is in the container.
Okay, thank you.
Yeah. Yeah, so that's where some of us get thrown off. We're like, wait, how do we bring that 6 and 12 into the problem? But the truth of the matter is we don't even need it. Okay, all right, so let's find the derivative, right? V becomes
dv over dt.
all right, 16 pi h.
16 pi dh over dt.
Now we can start plugging information in, right? We're trying to find DHDT. Oh, it says here, yeah. Sorry, at what rate is the height of the container changing? So I forgot to indicate that is what we're looking for. All right, that's our goal, right? We're trying to find DHDT. We have dVdt, so I think we have everything that we need to get to get the information that the problem is asking for. So I replace dVdt with -2. Divide both sides by 16 pi. And what's our unit of measure?
Inches per hour.
Yeah. Okay. All right, what's next? You can ask questions about problems that we did in class as well. Or if you're working on a problem and you just have a specific question about a problem, we can do that as well.
Could we do number 7?
Mm-hmm.
Thank you.
Okay, so we did number 7 in class, but I think it's good to review through the steps. Okay. Let's see. Pam, Yvonne, you guys are both in my 7th period class, right? Do you guys get a chance to finish number 7?
I think I got almost there. I'll get my notes out.
Yeah, so see if you can finish that problem. And I'll talk through the beginning for Joey here. So we have a water tank, height of 40 feet, radius of 30 feet. So those are the dimensions of our tank. R and H are the dimensions for our water level. We know those are changing throughout. Leaking at a rate of 2 cubic feet per minute. So we know that's dVdt. When the height of the water is 30 feet, that is H. So we don't want to confuse this with this, right? So that's the radius of the container. This is the height of the water level at a specific moment in time. We know that this is a variable. This value is not going to be the same a second earlier or a second later. So this is a very specific value, but overall, we know that the height of the water level is always changing. So thing to keep in mind is that we do not want to use this value until the very end. We're not going to use it until our dvdt, our dHdt shows up, or some sort of a derivative shows up, because if we plug it in too soon, it's going to cause issues. Okay, we don't want to lose the fact that this h is not constant. Okay. We know that we're dealing with a volume equation. We know that we have to involve similar triangles. So I'm going to build my proportion here. So small radius is to the big radius, and small height is to the big height. Cross multiply, solve for r. I get 30 over 40h, or 3h over 4, and now I'm ready to plug in. Okay. Oh, so the reason that I know to solve for r is because I'm looking for dHdt, right? Because I'm looking for dHdt, I know that the quickest path to dHdt is through h. So if I can get my equation in terms of h, the derivative process will just naturally produce dHdt for us. So that means the most efficient way to get there is to replace r in terms of h. So that's what I'm going to do, replace r in terms of h. Put 3h over 4 in for the r. And let's see if we can clean up our equation here. All right, any questions with this step?
I don't have any questions.
Okay, looks good. Now, some students, sometimes they want to start putting the 30, so still too early for the 30. Some students, they want to expand this out, which is good, right? But let's see how far we can, or how far we can push these terms together so that we can get it cleaned up for our power rule. So make sure we square everything inside, right? The 3 gets squared, the h gets squared, the 4 gets squared. Okay, what's next? How can I clean this up even more?
Could you multiply h squared to h dvh
Good.
cubed?
That's important, right? I see some students wanting to do power rule, bringing down that too, but we got to push these together, okay? If you start doing power rule and this h is still sitting here, that means technically that means you got to go through product rule, right? So it's easier if we just put the h's together. Okay. What about these numbers? Can we do anything with these and push those together? What can that become?
Can we cancel the 3 and the 9?
Sure, yeah, you can do that. You can multiply it out or you can cancel out, but yeah, either way, we want to push this together, right? So what happens then if you cancel these out?
We'll get 3h squared over 16.
Okay, good. That's our coefficient, all pushed together, cleaned up. We want the h's together. So this is where I want us to be before we find the derivative. Okay, so that's an important step to get to. If you get to this step, everything that comes after should be a little easier. Okay, the hardest part is trying to get from here through these steps here. All right, any questions? Okay, we're ready for the derivative. So someone want to walk through the steps? What comes next?
So would you leave 3 pi over 16 because it's a coefficient?
Good. That's right. That's not going to go anywhere, right? These are the things that are changing. This is not going to change.
Okay. So would become 2h dh over dt?
2h, dh. Close, close. Let's do the left side first, right? V becomes
dv over dt.
dv dt. All right, Joe, you said the coefficient stays, right? So I'm going to rewrite that.
Oh, I think I forgot to leave. I forgot to subtract 1 from the derivative. So it'd be 2h squared dv dt or dh dt.
Close. What's power rule? What's h cube's derivative?
2h squared.
Someone else want to jump in? You're close. You're close.
3h squared, right?
Yeah. So we bring down the 3 first, and then we subtract 1 from the exponent.
Okay, sorry, that was my bad.
Good. And then dh dt, right? Good. All right. So this entire problem, this is the only calculus step. Everything before is getting the equation ready. Anything after is just cleaning up. So this is the one calculus step that we're dealing with here. All right. Any questions here? Okay, what's next?
Would you plug in your given?
Yeah, we can start plugging our given. Yep. That's perfectly fine. I think for me, I like to clean up a little further, but you can, but yes, you're free to now use that 30. That 30, anytime before is too soon, but this is the point. Once these show up, you're ready to go. That 30 is ready to go. So I'm going to clean up a little bit more, but yes, we can start plugging in. Okay, so I can replace dv/dt, I can replace h, and that clears the way to help me solve for dh dt. Multiply everything out. You can use your calculator to do the work for you. Multiply by the reciprocal to bring this fraction over to the right, to the other side, so I can get that dh dt by itself. So we may want to simplify some of this earlier. Otherwise, the calculator may not be able to reduce that fraction for us as well. Let's see. So -2 times 8 over. This can reduce even further. All right, so we're almost there, right? Negative 2 times 4 is negative 8. Units of measure, feet per minute. All right, what else? Any questions? Any?
I had a quick question. So, just to make sure, like, when do we exactly use our power rule? Because I know sometimes, like, we just need to refrain from using it.
Yeah, we do power rule once, and it's from here to here. That's the only time we use power rule.
Okay, and is it just to like when we have an exponent, or is it? Or
Yes, and it's when we have exponent and we have everything cleaned up. So we don't want any h's. We don't want multiple h's. We don't want any variable in the denominator. A lot of with power rule, we want to make sure that everything is nice and ready, right? We don't want radicals. We don't want variables in the denominator. We don't want any parentheses with multiple h's. So this is not ready for power rule, right?
right.
Because if you technically you could go through derivative, but then you got to go through product rule, you got to go through chain rule. It's just a mess that we can avoid.
Okay.
So we know that we're ready for power rule when we have our conditions met. No parentheses, no variable in the denominator, and no radicals. That's when you know you're ready. Okay, any other questions with number 7? All right, what's next?
I just had one more question on 3B.
Mm-hmm.
In my class, we just learned L'Hopital's rule today, so I'm still kind of
All right,
used to it.
so this is L'Hopital's rule. All right, what's the first step? What's the first thing we do with any limit problem?
Direct sub.
Yep, we're going to substitute 1 in for x and see what we get, right? We don't want to jump to conclusion. So let's see what we're dealing with. Okay, so 1 plugs in for x, 5 minus 4 minus 1. And what do we get?
Would you get 0 over 0?
So that means there's a hole in the graph. There's an answer at the end of the process, and that means we can use L'Hopital's rule. So we have the license to use L'Hopital's rule. We can find the derivative of the top, and then separately, we'll do power rule for the bottom as well. What's the derivative of each of the terms up here?
20x to the third minus 8x.
Good.
And then for the bottom, would it just be -1 minus 27x squared?
Good. So as soon as we do L'Hopital's rule, what do we do immediately after that?
Do we do direct substitution again?
Yeah. Plug in that 1, right? substitute in 1 for all the x's. Okay, does that get us to a real number?
Yes.
Yeah. So we could end up doing a repeated L'Hopital's rule, but we only can do a repeated L'Hopital's rule is if this direct substitution produced another 0 over 0. If we get another 0 over 0, each 0 over 0 will give us the license to do L'Hopital's rule once. Okay. But what we don't want to do is we don't want to keep finding the derivative without direct substitution, right? So each 0 over 0 will give you the license to do L'Hopital's rule once. But here we end up with a real number, so that's our answer. We can reduce All right, good. What else do you guys want to see?
I don't have the worksheet in front of me, but can we do another one of the cone problems?
Yeah. Let's see if I find one. All right. All right, so let's start this problem here. This is number 3. This is on the back of the notes for my students. Similar triangle shadow problem, second page. All right, so 40 feet across, 40 feet deep. Water is leaking out at a rate of 80 cubic feet per minute. Okay, find the rate of change of the radius of the water. Okay, so now we're looking for something different, right? Rate of change of the radius. Okay, so what are we looking for? What's that variable?
Would it be dr over dt?
Yep, dr dt. Good. When the water is 8 feet deep, so this is what? It's h, right? So we're talking about water level here. We know that water level is not going to be staying constant the whole time. So so again, we're not going to use. Okay, this is safe to the end. Okay, at least until your dH/dt, your dV/dt, your dR/dt shows up. Right, you got to have that. Got to show that differential before we can even touch that 8. Okay, let's set up our proportions. Height is 40. Okay, what's my radius?
20.
20. Got the R, got the H. So let's build our equation here. Small radius is to big radius as small height is to big height. Cross multiply. Okay, we're trying to make a decision here. What do we want our equation in terms of? We want one variable to disappear and one variable to be kept. What do you guys think?
Do we want it in terms of dr over dt?
Okay. Yes, we're looking for dr dt. So what do we want our equation in terms of? R or H?
R.
Yep, R is going to give us the fastest path to dr dt. H can get us there too, but it's just a little bit more steps. So this is guiding our decision, right? We want dr dt. The fastest way to get dr dt is if we have R's. So that means we want the H to disappear. So we're going to solve for H and replace H. Okay, so there's my equation. I'm going to solve for H, divide both sides by 20. Okay, substitution. This goes in for H, sorry. Hey, how does that look to you guys? Good so far? All right. How can we clean this up? Because we don't want to do power rule just yet.
Could you
Can we
multiply
plug
the?
in
Oh, sorry, go
the
ahead.
rate? I was just saying plug in the rate.
Plug in the rate. What do you mean?
Negative 80 feet, so dv over dt.
You mean, well, we don't have dv/dt yet. Are you talking about finding the derivative?
Oh no, my bad. That's too early.
Yeah. So there's something that we want to do on the right side.
Could you multiply r squared and r?
Yeah, right. We want to try to push things together, right? We shouldn't be staring at multiple versions of R. We should be able to merge some things together. So what does that become? R squared and R becomes
R cubed.
R cubed. And I can put that 2 with the what?
The pi.
pi over 3, right? So I'm gonna push the numbers, put the coefficients together. I want to merge the variables, so that's something to keep in mind, right? We don't want to have multiple versions of R, right? We want to push those together. Otherwise, our calculus step is going to be messy. The nice thing about multiplication is we can rearrange however way we want. So now I have a nice clean equation. My derivative should be easy from here. All right, how does that look to you guys?
Good.
Okay. All right, so let's walk through our derivative. Okay, Vivon, you want to take this one? Walk us through the steps.
Okay, so we plug in negative 80 feet or dv over dt.
Okay, good. So let's find the derivative first, and then we can start putting information in. So tell me what the full derivative is on both sides of this equation.
It'd be 3r cubed. I mean 3r squared.
Okay. And then v becomes what?
Dv over dt.
Good. And then when you find the derivative, what else do we need to include?
Dr over dt.
Good. Yeah. So dv dt shows up, dr dt shows up. All right, so this is important, right? I want you guys to be comfortable here. Any questions from here to here?
I have no questions.
Yeah, no questions?
Yeah, I feel pretty comfortable with that step now. Thank you.
Good. All right, so let's clean this up. And then now we can work some values in. However, okay, there is another step we got to worry about here. So let's see here. Let me clean this up. Let me get the 3's to cancel out. I can go ahead and put that negative 80, right? But there's still something that we don't have a direct information about. Is we want R. Do we have the radius of the water level?
No.
No. But we have something related to it. What do we have?
We have, like we did the relationship earlier between little r and little h.
Mm-hmm. So we have the height of the water level. So maybe we can find a way to connect these two, right? So what's the relationship between radius and the height of the water level?
Is this when we plug in 8 into the proportion?
Yep, that's right. Yep, we can plug it into the proportion. So basically you can use any of these. You can use this one or this one or this one or this one. Any of these will get you to what we want for R. But yeah, you can plug into the proportion here. So which one do you want to plug into?
H equals 2r.
Okay, let's do that. So that makes R equals what?
4.
Yeah, so now, okay, now we're ready. Now we have everything we need. Right? Clear path to dRdt now, right? Four squared is 16. 16 times 2 is 32. Okay, divide both sides by 32 pi. reduce the fraction. I can take a 4, or more than that, right? I can take a
You can take 8.
8, okay.
Or actually higher. You can
16?
take 16, yeah.
Yeah, I can take 16, right? Notice pi stays in the denominator, okay? We don't move it up.
If pi was in the numerator, like for another problem, could you move it to like the side of the fraction, like
Yeah,
next
yeah,
to it?
move it to the side, right? If pi is in the numerator, you can have it up here, you put it to the side. But if it's in the denominator, this is the only place it can be.
Oh, thank you.
All right. Do you guys all feel hopefully more comfortable with cone problems?
Yes, definitely.
Good,
Yeah, I feel much better. Thank you.
good.
Yeah, me too.
All right. Oh, good, good. Yeah. So I think the trouble that students have is trying to. There's just a lot of steps, right? And it's easy to get lost. And so, the only way to get better at it is just to see more of it, right? The more you see, the more you ask questions, the more you connect the dots, you're able to kind of follow the process a little better. All right, so I encourage you guys to continue working through the test review, and I'll have another review session tomorrow morning, 8 o'clock. I'm gonna change to 8 o'clock, and also 3:30. Okay, so I think it's good if you can work through that test review. That way, the questions that you may have is going to be more specific. You're going to be able to progress more if you have specific questions that you're coming into future review sessions with. So, all right, thanks guys. Hope you guys have a good afternoon, and hopefully, if you have any questions, we can address those tomorrow during help sessions, or you can send me a message over Remind as well.
Thank you.
All right, great
Thank
job,
you.
guys. See you
Thank
tomorrow.
you, Mr. Thank you, Mr. Have a great day.
Yeah, have a great day. See you guys.